Somewhere in the distant universe, astronomers spotted two supermassive black holes consuming cosmic materials as two galaxies are on the verge of merging into one. This is the closest black hole merger we have ever witnessed so far, which makes it a lot more fascinating than what we initially thought. Our Milky Way is on a collision course, which means in about 4 billion years from now, the Milky Way and its neighboring galaxy Andromeda will begin a spiraling gravitation dance to form one huge galaxy. Such a phenomenon is not rare by any means in the universe, and they are the important building blocks for larger-scale cosmic structure. But these newly discovered will give us more clues about what exactly will happen if such a thing takes place. So keep watching till the end to know why this discovery is crucial to our understanding of the universe. Astronomers have been working for quite a lot of decades now, not only to prove the existence of black holes, but also to understand the physics of black holes and their surrounding environments. We already have some indirect evidence from various astronomical studies confirming the existence of black holes, including the investigation of nearby objects that are subjected to the gravitational pull of a black hole. These circumstances are very well explained by the general theory of relativity, but there were still so many things that were a mystery, like the direct observation of the immediate environment surrounding a black hole known as the event horizon. But that changed back in April 2019, which is a topic for another video. Black holes drive our curiosity for the right reasons. They might remind you of a shadow puppet theater where you are enjoying the show based only on the effect of light on the objects that create the shadow, because they trap all matter that falls into them, including light. Yes, that's right. In theory, giant black holes, each about millions or billions of times heavier than our sun, must collide and merge. Such mergers can channel huge volumes of material into black holes, sparking a violent astrophysical outburst that will shake formation of cosmic objects and several other processes in their host galaxies. Up until now, astronomers were not able to observe this phenomenon, but things are now changing because an international team of scientists announced the discovery of two active supermassive black holes close to Earth in a new study in the astrophysical journal Letters. The discovery was shared at the 241st meeting of the American Astronomical Society, which was held in January 2023. As of now, this new research paper pushed the limits for what is possible to observe. Astronomers have already observed a pair of binary black holes in even closer proximity to each other before, but only with a radio telescope. With the new study, the team can confirm their findings using multi-wavelength data from different telescopes, which is an important step because this field is known to have several false positives. These black holes are at least 125 million and 200 million times heavier than the Sun, respectively, and luckily, they are at least 500 million light-years away from us while gobbling up gas and dust at the center of the UGC 4211 galaxy. These black holes will start circling one another in orbit, eventually crashing into one another and creating one huge black hole. After observing them across multiple wavelengths of light, these black holes are the closest by far. The distance between black holes is fairly close to the limit of what we can detect, which is why this is super exciting. This pair was really exciting because they're so close to each other and they're so nearby, says Chiara Mingarelli, one of the study's authors and an astrophysicist at the Flatiron Institute in New York City and the University of Connecticut. So why is this important? Black holes are considered to be the laboratories for testing fundamental theories that explain how our cosmos works on the largest and the smallest scales. The galactic mergers are very common in the distant universe, which makes them harder to observe using Earth-based telescopes. Our study has identified one of the closest pairs of black holes in a galaxy merger, and because we know that galaxy mergers are much more common in the distant universe, these black hole binaries too may be much more common than previously thought, said lead study author Michael Koss, a senior research scientist at the Eureka Scientific Research Institute in Oakland, California, in his statement. What we just studied is a source in the very final stage of collision, so what we're seeing presages that merger and also gives us insight into the connection between black holes merging and growing and eventually producing gravitational waves, Koss said. The project began about 10 years ago when Michael Koss started using some of the world's largest telescopes to search the sky for a few active pairs of massive black holes. After observing nearly 100 objects, he found 6 hidden merging pairs, and out of this only UGC 4211 stood out, being much closer together than the rest. The reason behind these high-resolution photos is because of UGC 4211's proximity to Earth. These two black holes are separated by about 750 light-years or about 230 parsecs, which means this is the closest pair of black holes that we have been able to confirm by measuring multiple wavelengths of light. These black holes' close proximity to Earth and each other will provide us a unique opportunity to study more about giant black hole mergers, and it might be the most detailed study ever because this time we will also be studying one of the most elusive byproducts of a black hole merger that is ripples in space-time called gravitational waves. You can see it. I mean, literally, you can see there are two sources, says Koss. These two black holes are now believed to be midway through their merger and will draw even closer together as the surrounding swarms of stars and gas siphon away their orbital momentum. The authors of the research paper predict that in about 100 million years, the two supermassive black holes will finally fully merge to become one. Such huge mergers are thought to be one of the most common contributors to the gravitational wave background, as the undetected totality of space-time ripples from sources scattered across the entire observable universe that is imprinted across the entire sky. Detecting and mapping this background will shield the cosmic merger history of supermassive black holes and several other cosmologically vital information. This discovery also suggests that there may be more merging black holes to observe than what we previously thought, and this time, we just got lucky. So if astronomers cannot see black holes, how do they photograph it or even study them? Well, they do it by observing the behavior of light around black holes. Astronauts understand black holes by observing the light around it, because they are surrounded by bright clusters of stars and warm glowing gas, all of which are ducked by the strong gravitational pull, so strong that it could even absorb light. In this case of two supermassive black holes, we have the images from the Event Horizon Telescope, where you could see black hole shadows flanked by the glow of superheated material whipping around it continuously. Black holes themselves are not known for their visibility. Each of the theories that we have today work well in its respective regime, but physicists currently do not understand how to create a single physical theory that would be applicable to the entire cosmos, which is why learning more about black holes is very important. There are more details of plasma physics that are still a mystery. The properties of hot gas surrounding and being pulled into black hole beyond the event horizon are not fully known yet. The understanding of these properties is crucial for interpreting black hole images, because it is this glowing plasma that produces radiation captured by radio telescope arrays. This glowing gas illuminates the shape of space-time around the black hole, and the observations from the Event Horizon Telescope will just help us better understand the properties and behavior of these mysterious structures of the cosmos. If a pair of black holes as well as merging galaxies that led to the creation are more common in the universe than what was previously thought, this means that there could be major implications for future gravitational wave research. Now, for those of you who don't know, gravitational waves or ripples in spacetime are created when black holes collide. It will still take a few 100 million years for this particular pair of black holes to collide, so you don't have to worry. But what's important would be the insights that are gained from this observation, as this could help astronomers and scientists better estimate how many pairs of black holes are close to colliding in the universe. Space-based telescopes and ground-based telescopes have observed the UGC 4211 across different wavelengths of light to provide a more detailed overview and differentiate between black holes, because each wavelength tells a different part of the story. And when you combine all of these data together, this will give us a clearer picture of how galaxies, such as our own Milky Way galaxy, turns out to be the way it is right now, and what it will turn into in the future. So understanding more about the ancient galaxy mergers will also give us more information about what will happen to our own Milky Way galaxy when it collides with the Andromeda galaxy in about 4 to 4.5 billion years. Only time will tell.